Hello everyone, I am Raviraj Saxena. I am pursuing PhD in Indian Institute of Science under Dr. T. V. Prabhakar and Dr. Joyce Guri. I am a CNI scholar and today I'll be presenting my work on vertiport terminal scheduling. I will start with the motivation, then I will show the background, then I will explain little bit about the mixed integer linear programming formulation of my work, which is the gist of it, and then I will show the results of the formulation, and then I will conclude my work. Nowadays, for the dense traffic like in Bengaluru, we, uh, we have one of the concept which can be a solution is the urban air mobility, which aims to address decrease the road congestion by using the urban airspace. So we have VTOL vehicles which are capable of vertical takeoff and landing. They can use the vertical dimension to navigate across the cities. So and because there will be battery power, so they are also sustainable. Now, these VTOL vehicles will require the vertiport terminals for landing, takeoff, refueling, and maintenance, which include also the passenger boarding and deboarding. So, for these terminals, we we will require the efficient scheduling algorithm so that we can all the traffic of the incoming and the outgoing vehicles can be managed. Now there are some this analogy can be drawn between the airports and the vertiport terminals. So these vertiport terminals are hubs which actually where all the VTOL vehicles will uh, arrive and depart, and all the passenger boarding deboarding will happen. So now, if you recall in a aircraft, uh, an aircraft will actually utilize the runway. It will first require the accelerate to require a speed to take off, and then it will climb to a altitude, and then it will go to a certain direction. Now for this whole length, only one aircraft can be there. But in VTOL vehicles, it can only just take off and land in vertically, and it can go in any direction right after takeoff. So this simple idea that flying in multiple direction and climbing, that can be exploited for at a vertiport terminal to increase its throughput and decreasing all its delay. Now for the scheduling algorithm, we have come up with a mixed integer linear programming formulation where we have an objective of minimizing a total delay incurred by each flight while maintaining some constraints. Now for a typical VTOL vehicle, it will depart the gate, it will travel through the taxiway nodes to the TLF pad, then it will vertically take off, and then it will climb over the surface directions. Now this is one here only one surface direction is shown. There can be multiple surface directions. So the in objective delay, if flight can have a waiting time at the gate where it has to wait because other flights are already on the taxiway. Then there's a delay because of the slower speed at the taxiway because it is congested, and there can be some delay over the surface direction, or because again for the separation requirement and the separation requirement if there's another other flights over the on this surface direction. The constraint are like we have a physical limit over the speeds of flight. There's some minimum and maximum time it will take to cover a link. The links are basically taxiways and the surface directions, and no overtaking or head-on collision are allowed over any link. Again, the taxiway or the surface direction. Then on ground and in air, we need to maintain a separation distance between all the flights, and then on TLF pad we need to maintain wake vortex separation where if a heavier aircraft has have takeoff, sometimes should be weighted by the following aircraft, so because there is turbulence in air, there can be then other ATM separation constraint can be there which needs to be maintained. So overall when we input we have some input to input the VTOL vehicles or aircraft for in this formulation, we will get a scheduling algorithm where we get for each aircraft, each VTOL vehicle, at what time it will depart the gate and at what time it will reach the node, any of the nodes. This way, our whole formulation will give us a scheduling algorithm. Now, here are the results according to formulation on a sample topology. Now we have a varied number of flights as input, and the formulation gives us a scheduling algorithm. So, because as we varied the number of direction, we have some delays, and as we can see that if we have only one surface direction, the delay is significant, and even having just two direction, the delay reduces significantly. So as we increase this number of surface direction, our overall delay keeps on decreasing, and which shows that delay incurred by each flight actually reduces when we increase the number of surface directions. And we can also observe that as we increase the number of flights, our delay actually keeps on increases because it increases the congestions. So this our formulation actually clearly shows that having multiple number of direction reduces the delay by more than 50%. Now, I would like to conclude by saying that we have a novel approach of incorporating multiple climb direction for the VTOL vehicles on the vertiports. And we have clearly shown that having more number of surface direction reduces the flight delays by more than 50%. And for the vertiports which have multiple TLF pad and surface direction, the throughput can be substantially increased. But these benefits need to be think about and should be associated with the cost before or for all the decision making. Our work has been accepted in IEEE International Conference on Intelligent Transportation System, that is ITSC 2023, and we have published this work with the title Integrated Taxiing and TLF Pad Scheduling using different surface direction with fairness analysis. Thank you.